Hello everyone, today we're gonna have a look at how to reverse a linked list in JavaScript. No, I'm just joking around. We're gonna have a look at how to predict house prices based on some features that we have about certain houses. So for that purpose, I'm going to have a look at the Kaggle dataset house prices advanced regression techniques. And to open that for you, it's an ongoing challenge on Kaggle that provides a dataset which defines a lot of features that you can use to predict house prices. And as you can see, it has some training and test data. And the training data has 81 columns, including the sale price. And the test data has 80 columns. So we will only use the training data for today, and if you want to, you can use the model that we're going to train to send your results to Kaggle. Okay, so we are actually going to use only a subset of the features for our model, and the subset of those features are chosen by going to the kernels and having a look at some of the exploration analysis on Kagglers. So the subset of features that we're going to use is the overall quality, which is the rate of overall material and finish of the house, which is a numeric value between 0 and 10. The greater living area, square feet of the ground area of the house above ground. The number of cars that you can put in the garage. The total square feet of basement area, the number of bathrooms, the year at which the house was built, and we're gonna, of course, take a look at the sale price and try to predict that. For the purposes of loading our data, we're gonna use again pop-up parse, and here's a snippet that you can use to load the data. But after loading the data, we will do some exploration of it. So let's first start with copying this snippet, and I'm already running Visual Studio Code in here, and as you can see, I have a pretty basic template that is similar to the ones that we've used previously. So I'm going to paste in the prepared data and the data loading itself. Please take note that all the tutorial and source code of this video will be included in the description below, so you can have a look at it. And let's get to the exploration of the data. So the first thing that we're having a look at is the overall quality of the houses. And as you can see, most of the houses are between this 5 and 6 score. Although more of the houses are of better quality than those that are not. Okay, so if we have a look at the living area, again you can see that most of the density of our distribution is actually within the 1000 and 2000 square feet. The year that the houses were built is pretty widespread. The distribution is pretty widespread, but most of the houses are still pretty recently built, as you can see. Okay, so if you have a look at the relationship between the year that the house was built and the price for it, you can see that generally speaking, newer houses are a bit more expensive. But that's not highly true in all cases. If we have a look at the quality of the materials and the price, you can see that a higher quality score pretty well explains a higher price, except that for a quality score of 10, you can see that the price varies a lot, and you might have some guesses about why this might be. For example, the living area for a house that is of quality 10 might be just something like 200 or 300 square feet or something like that. and in that case the price might be a little might be lower than that of some houses that are bigger but of lower quality. Okay, so the final feature that we're going to have a look at is the living area related with the price. And as you can see, the relationship in here is pretty significant and pretty linear too. So we will use this feature when we're building our simple linear regression model to try to predict the price of a house. But that will be in the next video. For this one, I'm going to show you how to load and pre-process the data so that you can build your linear regression model. Okay, so I'm going to skip this section which explains what a linear regression is, what a simple linear regression is and multiple linear regression is. And I am going to go to the data preprocessing part. In here, you can see that we have a section on categorical features and a section on feature scaling. So in our case, once again, if I go to the features, you can see that garage cars, number of bathrooms, and overall quality are actually categorical features. So we need to handle them in a bit different way compared to numerical ones. And we're gonna do something called one-hot encoding that we had a look at previous videos. So to do that, I'm going to create a function that we'll call one-hot in our editor. But before that, I just wanna say a couple of words about categorical encoding. So why do we need categorical encoding? The thing is that numbers are generally dependent on order. So what this means is that if we have the numbers 1, 2, 3, 4, etc., this might mean that 2 is better than 1 and 3 is better than 2, etc., etc. So there is some relationship based on the ordering. But when you have categorical variables, that might not be the case. For example, if you have males and females in your dataset, so if you have like sex female or male and you want to encode that, if the males are represented with zeros and females are represented with ones, it doesn't mean that 1 is greater than 0 in this case. So we have to represent those values in some other way, and that other way is one-hot encoding. We will use that for today. Please note that actually for this problem, it might not be necessary to do that, but I'm going to show you how to do it anyway. And you can try to train your models without one-hot encoding and compare the results if actually the models are performing better. But for now, let's have a look at how to encode categorical variables. For that purpose, I'm going to define a function called one-hot, which will take 2 parameters. It's going to take the value of the variable and the number of categories that this variable can have. So it will be one-hot. The first variable, the first parameter is going to be called val, and the second one is the number of categories. So in here, I'm going to build an array that uses tf1hot. I am passing in the value, the number of categories, and then I'm going to extract the data from one-hot. So let me show you actually what is happening if you use a one-hot in here. So if I go to the console, and we see that Sorry, this link is not working, so let me just check that. Okay, so the link was incorrect, so I'm going to use this one, and now the data is loading correctly. So if I have a look at the first row of the data, you can see that we have a lot of features in here. And if I have a look at the garage cars, we are having two car capacity in the garage for this car, for this house. And if I call one hot on that, and remember that the number of cars can be up to 5, I'm passing this as a parameter, and I'm receiving an output, a result of array one hot encoded representation of 2. We have 5 values, and at position 2 we have 1. Okay, so that's pretty much what one hot encoding does. The next thing that I'm going to need is feature scaling. And feature scaling is a transformation that allows you to put your values in a similar range. In our case, that range is going to be between 0 and 1. The reason for this is that we can use feature scaling to make training our models faster. And if you want more details on why this might be the case, please note that we are using gradient descent as an optimization or training method. And there is a article, or rather a paper that is linked in here that describes some interesting results based on feature scaling your data related to deep network training and other methods. So what is feature scaling? In our case, we're going to do just this. We're going to have a value, and from that we're going to subtract the minimum of all values that we have in the vector, and we're going to divide that by the maximum of all values in this vector, and from that we're going to subtract the minimum of all values. So in this way we're going to receive a range of between 0 and 1. Okay, to do that with TensorFlow, we're going to define a function called Normalize, and this function is going to work with tensors, so we don't have to write our own mathematical operations, and we're gonna just rely on TensorFlow to do this job for us. And you might notice that we have a two-dimensional tensor of data, but this function will work on any dimensional tensor. So let's define Normalize. It's going to accept a tensor, and we're going to do a division, and for that division we're going to define the this part here, and this is going to be the difference between the tensor and the minimum value of the tensor. And for the bottom part we're going to have the maximum value, and from that we're going to subtract the minimum value. So this will normalize or put in the scale of 0 to 1 our data. Okay, so we have these two helper functions, and the last thing that we have to do is start using those and convert our data into tensors. To do that, I'm going to define another function which we're going to call create datasets. And for that, I'm going to pass a couple of parameters: the data, the names of the features, the categorical features that we're going to convert to one-hot representations, and the size of the test data that we want to use. Okay, so first I'm going to transform the features from our data, and to do that I'm going to define a constant called x, and in that I'm going to map over all rows in our data, and then for each feature I'm going to define a flat map. And a flat map is just a way to flatten a resulting array from the map function. So when we do one-hot encoding, one-hot encoding is going to return an array, and we just want to append all values from this array to the resulting values for now. So we're going to use flat map for that, and we're going to check if categorical features has this feature. I'm going to call this F for feature. Then I'm going to return one-hot encoding version of it, but I'm going to check if this is defined value, and if it is not, I'm going to pass in a 0. So we're going to check for missing values in this way, or else I'm going to take the value from R, and I'm going to need a second parameter that tells me how much unique values are there in this category or in this feature. And for that I'm going to come over here and define a variable category count, which defines for overall quality we have 10 different values. For garage cars we have 5 different values, and for full bad we have 4 different values. And then I'm going to pass in the variable category count and the name of the features that we're interested in. And if this feature is not categorical, I'm going to return just the value of this feature, and I'm going to check if this value is undefined or null, and I'm going to return a 0, or I'm going to return the value itself. Okay, so now that we have our features in X, I'm going to create a tensor, and I'm going to apply the normalize function on that tensor. Okay, so to do that I'm going to create another constant called x underscore t. Sorry for the naming convention in here. Let's say it's xt from tensor, and I'm going to normalize this, and I'm going to create a 2D tensor from x. So now we have the x tensor. Again, we are trying to predict the price of the houses, so I'm going to need to process the labels or the sale price as well. To do that, I'm going to create another tensor called y, and in here I'm going to have a look at each row of our data and check if the sale price is defined, and if it's not, I'm going to say that it's going to be a 0, or else it's going to be the sale price. So again, handling missing values in here. Okay, so now we have those two tensors, and we need to do a bit more work to be done with this function. The last thing that we have in here is actually the parameter that describes how much of the data should be left for testing and how much of it should be left for training. So I'm going to calculate the split index, or the position at which the data should be split. And to do that, I'm going to use the parameter test size, and I'm going to subtract it from 1, since 1 is all the data, and I'm going to multiply that by the the number of rows in our data and convert that to an integer. Okay, so now that we have the position at which we want to split our data, I'm going to define two constants, xtest and ytest, and I'm going to use tf_split to split the x tensor at position split index, and I'm going to have it split until the index that we want. Okay, so I'm going to do the same thing for the y, and in here I'm going to pass in y. So okay, we have xtrain, xtest, ytrain, ytest. So the last thing that we want is to return the result, and to do that I'm going to return xtrain, xtest, ytrain and ytest. Okay, so we have our function called create datasets, and the thing that we want right now is to call this function with the appropriate parameters. So the features that we're going to use are the following: overall quality, greater living area, the number of cars in the garage that can be put in the garage, total basement square feet, so all right, full bath, the number of bathrooms, and the year at which this thing was built. And of those we have a couple of categorical features which are going to be wrapped in a set, and I'm going to get from here all of those and then remove those one. Okay, so overall quality, and the number of cars that can be put in the garage, and the number of bathrooms. So we have the features and the categorical features. So I think we're finally ready to call our function, and remember our function returns xtrain, xtest, ytrain, ytest, and I'm going to pass in the data, the features, the categorical features, and I'm going to reserve only 10% for testing of our data. Okay, so let's check our tensors and see how we did in here. Okay, so if I come and say what is the size or what is the shape of the xtrain, we have this number of rows and we have 22 columns. This is expected since we're expanding the number of columns using one-hot encoding. So this is the xtrain shape, and what about the ytrain shape? The ytrain shape is 1, 3, 14. Okay, so one last thing that that we haven't got into is the fact that we need to convert the. Oh no, that's pretty much it. Okay, we're good. Yep, we're good. Okay, so let's have a look at the x test. Have a look at the shape of that. And for testing, we have only 147 rows. Okay, so in the next video, I'm going to show you how to use this dataset and build a simple linear regression model at first, and then build a linear regression model and have a look at how those two models compare, and can we actually predict house prices well. Thanks for watching. Please subscribe. Bye bye.